Until recently, we had no clue what actually existed at the end of the solar system. The discovery of dwarf planets and asteroids on the outer side of Pluto's orbit was relatively recent in 1992. In recent years, however, we have finally learned what really exists very far from the Sun, based on data collected by the famous New Horizons mission. Hello everyone. So, what is there? Why is there a challenge for future spaceships? What does it have to do with ancient legends? Welcome to Tipchen. Are you all ready? Then we're about to begin. Live on.
Wipe your eyes, you can't let them see a thug cry. You looking in the thug eyes. It's a funeral, let the doves fly. This is when the thug cry. You looking in the thug eyes. It's a funeral, let the doves fly. This is when the thug cry. You're trying to survive.
In 1500, the great composer Richard Wagner adapted this story into an opera inspired by this story, which has been adapted into films many times in the 20th and 21st centuries. One version of the story, the Nordic The Legend of Wellsunger, is just right for an episode in today's film. Siegfried, or Sigurd in Viking, accompanies King Gunnar to the rare city of Brunhild, a warrior woman whom Gunnar hopes to marry. The city of Brunhild resides on the summit of Hindle and is surrounded by a raging wall of fire, and only Siegfried can cross that wall. After that, in order to avoid revealing too much plot, please go to the opera or movie. Because this is not a channel for medieval European history. Among the whimsical myths and legends of various peoples in the world, the legend of the firewall is not the most bizarre. From observations of the universe in recent years, we know that it may actually exist. The whole of the solar system we live in is like Tyndall Peak. The solar system, surrounded by a wall of terrifying heat of 50,000 degrees Celsius. 50,000 degrees is a high temperature that is 10 times lower than the surface temperature of the Sun. The first clues that showed the existence of the firewall came in 1992, in the analysis of data received by the famous probe Voyager. However, the incompleteness of the data can be interpreted in hundreds of ways. Therefore, although scientists have expressed one or two opinions on this topic has been shelved, waiting for the opportunity of the emergence of the latest probe that can surpass the Voyager. The time finally came after the launch of New Horizons. It is the first probe ever to survey Pluto in detail. In 2018, probes discovered that wall. Brightly flashing grain, extremely high temperature, is called the hydrogen wall. Where does it come from? Will there be any danger when human spaceships pass through in the future? Will the future cosmic Siegfried cross this wall? The Sun and the solar wind are used. To understand how the hydrogen wall is formed, let's briefly explain the solar wind. Speaking of the solar wind, the only thing that usually comes to mind is a flare and complains that it makes you feel uncomfortable. Or will it extend the imagination to future solar sailboats? The solar wind is a stream of charged particles ejected from the Sun's corona. The corona is the outer, very hot part of the Sun's atmosphere. Particles are heated and accelerated in the magnetic field created by the Sun, and are ejected out of outer space at extremely fast speeds. If the solar wind travels in the interstellar matter at the speed of sound, that is, more than 100 kilometers per second, it is called the heliosphere. In the vicinity of the Earth, deep inside the heliosphere, particles of the solar wind travel at supervelocities of hundreds of kilometers per second. And the number of particles is staggering. Researchers estimate that the wind from the Sun releases about 1 million tons of material every second. The speed of the particles of the solar wind, the further away from the Sun, the slower it will be. On the outer side of Pluto's orbit, about 75 to 90 from the Sun, the velocity drops below 100 kilometers per second. Here, particles released by the Sun collide with walls of gas filled with interstellar space. This area is called terminal shock, which is called termination shock in English. About to pass the terminal shock wave, the solar wind can still advance in the thick interstellar body, but it will not be so smooth. Although the particles of the solar wind are exhausted after their long journey, the outer layers have been holding it back. The particles that have lost their power slow down. They become part of the interstellar material, and gradually cannot move forward. This happens where scientists call the heliopause. Here is the end of the heliosphere, the beginning of interstellar space. If the rotation of the Sun and the revolution around the center of the galaxy are no longer, it is believed that there will be no movement, and all directions will be the same structure. However, the Sun is spinning, and the magnetic field is also revolving around the axis of rotation, so scientists call this swirling structure heliosphere current sheet. On the other hand, the orbital motion of the Sun and the interstellar matter is likened to a ship speeding up to ride the wind and waves. Because stars other than the Sun also emit stellar winds into the outer cosmic space, interstellar matter will also fill that wind. The resulting vibrations and ripples of the Sun are called bow shocks. Take the bow wave generated by the bow of the ship breaking the wave as an analogy. Wall of flame. The high-temperature hydrogen wall is not only the Earth, but also very far away from Pluto, where the bow shock wave occurs. As for the formation mechanism, it is still not fully understood. It is possible that the interstellar gas heated by the double explosion from the Sun and the stars other than the Sun is continuously squeezed by the motion of the Sun, thereby causing frequent bow shocks. In a recent study, large-scale 3D maps of the solar wind, heliosphere, and heliopause were produced. The English of the heliosphere is heliosphere, which means the sphere of the Sun, but according to the results of this study, it seems that it is more suitable to be called helioveil, and the veil of the Sun, because it really covers the Sun with a thin layer like a veil. The thickness of the heliopause directly in front of the Sun's motion is relatively thin for the center of the Milky Way to rotate. On the other hand, the opposite heliosphere is much more expansive, so the environment there may be less extreme. But all this is our hope. The current solar system, like the city of Brunhild, is trapped in the castle of Tyndall Peak surrounded by walls of fire. Whether it is a cosmic visitor like an alien Siegfried of the galaxy or King Gunnar, or the day when humans leave the solar system, this wall of fire must be overcome. Voyager should be able to easily cross this wall, because the wall is actually very thin. In fact, the Earth also has a very high-temperature atmosphere with an outer atmosphere and a thermosphere. Although the temperature of the hydrogen wall is several times higher, the Earth's atmosphere is also very high, and the spacecraft and probe are also intact. However, the future spacecraft should be larger than Voyager, more like the size of a small city. In this case, the wall of flames is a big problem. With so much modern science, we still have the hope of if the wall is to avoid it and then walk through it. If only the heliosphere is the thinnest and there is a wall in the direction of the Sun's advance, first go in the opposite direction of the advance direction, then change the direction at a suitable place, and then pass through the wall. For a spacecraft traveling at the speed of light, it would take a few years at most to pass. Strong shields and force fields could even be developed to allow spacecraft to pass through walls of hydrogen gas unscathed. Our film today comes to an end imagining a bright future. Thank you all so much for watching. Hope you all enjoy our videos. Even so, let's not be so pessimistic from the start. In fact, since ancient times, humans have had different fantasies about the universe and the stars. Thank you in advance everyone. Then, see you next time. Bye.